Most of the universe is invisible. And we don't just mean it's too far away or it's too faint to see. We mean it is literally invisible. It doesn't shine, it doesn't reflect, it doesn't interact with light at all. Here's the strange truth. If you add up everything we can see, stars, planets, gas, dust, and even you and me, it amounts to only about 5% of the universe. The rest of the 95% comes in two mysterious forms. One is called dark matter, the other dark energy. Together, they dominate the cosmos, and yet we still don't know exactly what either of them really is. Hello and welcome to Astrobitica, your home for space news. Here we take the biggest mysteries of the cosmos and turn them into something you can understand, remember, and share. Before we begin, make sure to subscribe and tap that notification bell so you'll never miss a journey into the universe. The story of dark matter begins in the 1930s, when Swiss astronomer Fritz Zwicky was studying galaxies in the Coma cluster. He noticed something odd. These galaxies were orbiting one another far too quickly. By his calculations, the visible stars and gas didn't provide nearly enough gravity to keep the cluster from flying apart. Zwicky proposed that some hidden mass, invisible, unseen, must be holding everything together. He called it Dunkelmatter, or dark matter. At first, few believed him, but decades later, in the 1970s, American astronomer Vera Rubin provided the crucial evidence. She studied how galaxies rotate and discovered that stars at the edges were moving just as fast as stars near the center. According to Newton and Einstein, that shouldn't happen. The outer stars should lag behind, unless there's more mass than meets the eye, invisible mass. Today we know that dark matter makes up about 27% of the universe. It doesn't emit, absorb, or reflect light. It doesn't interact with the electromagnetic force. And as far as we can tell, it interacts mostly through gravity. So what could it be? Leading candidates include exotic particles like WIMPs, or weakly interacting massive particles, or hypothetical particles called axions. Physicists have built underground detectors shielded from cosmic rays, hoping to catch the faintest interaction with a dark matter particle, and so far, nothing. It might also involve whole families of particles we haven't discovered yet, or perhaps a modification to gravity itself. But until we capture it directly, dark matter remains an inference, invisible, yet undeniable in its gravitational pull. Without it, galaxies wouldn't exist, stars would drift apart, the grand structures of the universe would never have formed. If dark matter is strange, dark energy is even stranger. In the late 1990s, two independent teams of astronomers set out to measure how the universe expansion was changing over time. They expected to find that expansion was slowing, tugged back by gravity. Instead, they discovered the opposite. The universe isn't just expanding, it's expanding faster and faster. Something is pushing the galaxies apart, a mysterious energy embedded in space itself. We call it dark energy, and it makes up about 68% of the universe. What is it? That's still a mystery. It could be Einstein's cosmological constant, a property of space itself, where empty space has energy. Or it could be a new, dynamic field we haven't yet discovered. Or perhaps it's something that requires us to rewrite the very laws of physics. Whatever it is, dark energy is the driver of the universe's future. If it keeps accelerating, galaxies will grow further and further apart until distant galaxies slip beyond the horizon of what we can ever observe. In the very far future, our night sky might be almost empty, with only our local group of galaxies remaining visible. So how do we study what we cannot see? Astronomers use indirect evidence. Dark matter reveals itself in how galaxies rotate and how clusters of galaxies bend light through gravitational lensing. Entire maps of invisible mass have been reconstructed by watching how background galaxies are distorted, like looking through warped glass. Dark energy reveals itself through the brightness of supernova, acting as a cosmic mile markers. By comparing their apparent brightness at different distances, astronomers can measure how expansion has changed over billions of years. Right now, major projects are underway. The Euclid Space Telescope, launched by the European Space Agency, is mapping billions of galaxies to track the influence of dark matter and dark energy on cosmic structure. The James Webb Space Telescope contributes by peering into the early universe, giving us snapshots of how galaxies formed, when dark matter and dark energy were already at play. Meanwhile, physicists at the Large Hadron Collider, or LHC, search for hints of dark matter particles, smashing protons together at near light speed. And underground labs around the world wait, detectors chilled to near absolute zero, hoping to catch the faintest whisper of dark matter passing through. Why it all matters. At first glance, dark matter and dark energy might sound like trivia, obscure details about parts of the universe we can't even see. But they are far more than that. They touch the very foundations of physics. If we solve these mysteries, we may uncover new forces, new particles, perhaps even new dimensions. Dark matter and dark energy could be the keys to unifying quantum mechanics with general relativity, the two great but incomplete pillars of modern physics. They also determine the fate of the cosmos itself. Dark matter gathered the first galaxies together. Dark energy now pulls them apart. The balance between these two shapes the universe's past, present, and future. So the next time you look up at the night sky, consider this. Every star you see, every galaxy you admire through a telescope, every glowing nebula in a photograph is just the tiniest fraction of what's really there. Most of the universe is invisible, and yet it is the invisible that holds galaxies together. It is the invisible that drives them apart. We live suspended between two great unknowns, dark matter and dark energy. Together, they make up 90% of reality. And until we understand them, we don't truly understand the universe or our place within it. If you learned something new today, give this video a thumbs up, subscribe to Astrobitica, and tap the bell so you never miss our next journey into the cosmos. Until next time, keep looking up and stay curious.